Hi everyone, today's lesson is a statistics test review for Algebra 2 Trig Advanced, honoring my number 2.1 and 2 and my soon-to-be new grandchild. So anyway, let's get started. First question is a question on finding the standard deviation and variance. So what you're going to start off doing is that you're going to calculate the variance and standard deviation by hand, but actually then we're going to check our answers on our calculator so that you know how to find the 5-number summary as well, because you will be allowed to use the calculator on your exam this year. So the first thing we're going to do is we're going to find the average, or we're going to find the mean. And so what we're going to do is we're going to add up all of these numbers and then divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers, and we're going to add this up. So was that 5, 10, 15, 16, 17, 18, 19, 20. So we have 20 divided by 10, which is 2. So my mean is 2. So what we do in order to find the variance first is you have to subtract 2. Each one of my data points minus 2. So it's sort of like this. You're going to take your data points, which is xi, and you're going to subtract each one of my values from the mean. And then I'm going to square that value. I'm going to find the average of that value, and that's going to give me my variance, is after I find my average. Okay, so let's do that. So first we're going to go to, and you don't have to put these in lowest to highest, smallest to largest, unless you're trying to find the median or something else like that. But it didn't ask you to do that, so we're not going to. So we're going to go 2 minus 2. So we're going to square that. Then we're going to say 3 minus 2, square that. We have 4 minus 2. We have 1 minus 2. 0 minus 2, 5 minus 2, 1 minus 2, another 1 minus 2, and then 3 minus 2, and then 0 minus 2. So we're going to find these values, and then we're going to find the average of all those values. Okay, so 0 squared is still 0. We have 3 minus 2 is 1, 1 squared is 1. 4 minus 2 is 2, 2 squared is 4. 1 minus 2 is negative 1 squared is 1. Negative 2 squared is 4. 5 minus 2 is 3. 3 squared is 9. Negative 1 squared is negative 1 squared is 1. Negative 1 squared is 1. 3 minus 2 is 1. 1 squared is 1. Whoops. And that should be 0 minus 2. 0 minus 2 is negative 2. 2 squared is 4. So let's add these up. We have 4, 5, 6, 7. 7 and 9 is 16, 20, 21, 25, 26. So I added all these up and I got 26. And I'm going to divide that. In order to find the variance, you take all these values and you add them up. This is my variance. And then you divide by how many numbers you had, which is 10. So my variance is 2.6. Okay, so that's my variance. It asked me to find the standard deviation. So basically I'm square rooting that. So I'm square rooting. So to find the standard deviation, you square root 2.6. And this asks, and it's about I think about 1.6, but this did ask you to put it in exact form. So putting this in exact form is just, let's see, we're going to go the square root of 26 divided by square root of 10, which is the square root of 26 over square root of 10. And let's see, that's 2 times 13 over, this is square root of 2 times 5. And so these 2's will cancel. I get the square root of 13 over the square root of 5, which of course we're not going to leave like that. We're going to multiply by root 5 over root 5. So I have 13 times 5, which is 65. So let me fix this. which is square root of 65 over 5. And again, this is my standard deviation in exact form, but approximately it's 1.6. Okay. Next question says the data at the right shows the cooling temperatures of a pot into a serving cup. It says that the brewing. Oh, I'm so sorry. I wanted to show you this before I went on. I wanted to show you this on the calculator just so you knew how to do that. So we are going to do that. We're going to go to New Document. We're going to go to Lists and Spreadsheets. And I'm just going to put data. I'm going to call it D for data. And I'm going to type in my data. My data is 2, 2, 3, 4, 1, 0, 5, 1, 1, 3, 0. Okay, you're going to click on Menu, and then you're going to go to Statistics, Stat Calculations, and One Variable Statistics. You're going to click on this X1, and there's my D for data. And what it did just now was this gave me, even though I didn't ask for it, it gave me my minimum, my maximum values, my median. It gave me my Q1 and Q3 in case I wanted to make a box and whisker plot, which you definitely will be doing on the test. Additionally, if I scroll down, it also gives me this value, which was my variant, or before my variance divided by, it was just a sum of all the differences. Let's see, what else did it give me? Oh, and it should have given me my standard deviation, which is right here, 1.612. This number 10 is how many numbers I had, my minimum number, etc. So the 5-number summary, if we were to ask you that on a test, your 5-number summary would include the minimum value, this one, your maximum value, 5, your Q1, your Q3, and your median, of course, which is your Q2. And I would expect you to make a box and whisker plot. Just a note, if I go to data and I go to summary plot, that's going to give me a histogram. You see that? But actually, I'm going to open a new page, and I'm going to go Control Doc, and I'm going to go to Data and Statistics, because what that's going to do is that's going to give me, let's see, that's going to give me right here D, and let's see what happens. Oh, that's my dot plot. I also want, let me see what I could do with this. Let's see. I don't want that. I want a plot type. I want a box and whisker plot. So what that did was that gave me a box and whisker plot, and as you can see, that's what it looks like. So, I mean, there's a lot of things that your calculator can do for you, and I would expect that you would familiarize yourself with that prior to taking the exam. Second problem says the data at the right. So this is cooling temperatures of a freshly brewed cup of coffee, and as it's poured from the brewing pot into a serving cup. Then it talks about, the temperatures. Determine the linear regression model for this data. Draw a scatter plot of the data and graph it. You also find the R value. And if there is another type of regression model that you think it looks like, you would put that in there. And also, which model do you think fits the data better? So we're going to start over. So I'm not going to save this information. I'm going to start a new document. I'm going to go to Lists and Spreadsheets. And in my top value, I've got time. Time's usually my independent, which is, I'm going to put T for time. And my B value is temperature, so I'm going to put temp. I guess maybe I'll put time for this, T-I-M-E. Okay, so I'm going to plug these values in. You could probably take that time to do that yourself. 8, and if you don't want to wait, you can pause the video and come back to that. So 18, I've got 22, 25. I have 30, I have 34, oops, 34, I have 30, 38, 42, 45, and 50. And then these values here, I'm going to put them going back up. 100.5, 102.2, I have 105.7, I have 109.1, I have, let's see, 113.2, 116.3, 123.5, 22 is 125.4, 134.6, I've got 141.7, I have 149.2, 158.1, 168.7, and lastly 179.5. Okay. So what I'm going to do is just click on my A game here. And then what I'm going to do is I'm going to go menu, and I'm going to go to statistics, and I'm going to stat calculations, and I'm going to go to my regression model. Okay, y equals mx plus b. I'm going to type in for x, I've got my time. For y, I have my temperature, and I'm going to press OK. And you just click on the arrows on the right. You are using your scroll pad, your trackpad to scroll over. What this has done is it has given me, because I typed in a linear regression model, meaning what I typed in was y equals the mx plus b. What it's doing here is it's giving me on the left, it's giving me my m, which is negative 1.5. It's giving me my b, which is 168. So I'm going to type those values in. So I've got y is equal to my m value. My m value, again, is negative 1.56. X plus b. B is 168.9. So this is my linear equation, is what it is. Now remember, from the linear regression video, that what I talked about was that you always have to graph a scatter plot, because just because I said that this was a linear regression model, it doesn't mean that my graph of a line is going to fit my data. So one thing to check is my R value. So my R value is negative 0.9, or excuse me, 0.9. My residual value, or my R value, should be the square root of, or the average of all these numbers. So this is the square root of this, which is going to be about 0.97. So here we go. So let's look at that and see what happens. So we've got our R value. This says our R value is equal to negative 0.96, but realistically it's the square root of the R squared value, so this should be positive. So just a note, I'm going to go here and I'm going to open up a new page. So we're going to go Control, Document, and when we do that, I'm going to go to Data and Statistics, and then I've got all my data here. So I'm going to see what this looks like. So I've got time is X, and my temperature is Y. And you have to ask yourself, do you think this looks like a line? What I'm going to do is I'm going to go Menu, I'm going to go Analyze, my regression model, and I want to see what this looks like as a linear model. Okay, there. So again, here's my equation of my line, negative 1.56 plus 168. Can you justify this being a line? Does it look like a line? So if it does, this is my linear model, and that's what I have. Okay, so here's the thing. I'm going to go Control Document, and I'm going to go to Data and Statistics again, and I'm going to type in my time, and over here I'm going to type in my temperature. And there I have the same graph again. See if I look back on the other one. Okay, I got it again. But this time, when I go to Menu and Analyze, I'm going to see for my regression model, it kind of looks quadratic. See that? Does that look quadratic to you? If it does, if that line fits the curve, this would be a quadratic. So you'd have to, and so like I could put that equation down. My equation would be, let's see, whatever this equation is right here, y equals 0.03 squared. So let's see here. So my equation would be y is equal to 0.03x squared minus 2.9x, and let's see, plus 180. So that'd be plus 180. So would this look more like a quadratic? Okay, so on the test, you are going to be given data. Your data is going to reflect either some sort of regression. It may be a linear regression. It could be a quadratic regression. It could be a exponential regression. Let's say maybe this is exponential. Let me see what happens with that. So we have Document, Data and Statistics. I'm going to say there's my time again. Here's my temperature. Let's make this and see, do you think it would fit better as an exponential? What do you think about that? Do you think that fits it the best? So do you think it's a line, a quadratic, or an exponential? So that's where you're coming from. You are going to have a calculator, and you're going to be able to decide what you think this is. If you think this is exponential, then you're going to write in here that this is exponential. All right, you're going to write your exponential equation. You're going to say y equals 171.4 times 0.988 to the x power. And there's my exponential equation. So which one do you think it is? Do you think it's linear, etc.? So you're going to be given data. Then, based on what you think is the best fit for the data, I'm going to ask you some questions, predict what's going to happen in, let's say, 65 minutes. And if I only went up to 50 minutes, what's going to happen in 65 minutes? So that's what you're looking at as far as the regression model goes, okay? Remember that the R value, as it's closer to 1, the closer it gets to 1, the more appropriate it is the more strongly fit it is towards the line variable. Okay, so then we have this equation right here, which basically says the Math 2C test has a minimum score of 200 and a maximum score of 800. So suppose that the mean score is 560 and the standard deviation is 91. So if the test scores are normally distributed, answer the questions using the empirical rule, which is the 68, 95, 99.7% rule. So what's going to happen is, first question says, sketch the normal distribution. So I'm going to do that right here. Okay, and so graphing that, okay, we're going to do this. All right, and it says that, let's see what I have here. The mean score, so this is the important score right here. That's my mean. And this, the standard deviation. So I know that my standard deviation is 91, and I know my mean score is 560. So let's put that value, that information here. So we have the mean score right there. Okay, that's my X bar, which is going to be 560. a second. Okay. So let's put that there, 560. Then we have a one standard deviation away. That's going to be 660 because 560. I'm going to add 91. So actually that's not 560. So we're going to take, for here, I'm going to go over here. I'm going to subtract no. I'm going to open up a new document, and I'm going to open up a calculator, and we have 560 plus 91, and so that value is 651. So this value, this value here is 651. That's one standard deviation away. 2 standard deviations away is going to be 651. So we're going to go back over here to 651. And we're going to add 91 to that again. And then I'm going to add 91 again. And so these are my values here that I'm going to be putting in. I've got, let's see here, I've got 651, I have 742, and then the third standard deviation away is 833, okay? So then I'm going to go backwards, and I'm going to start with 560, and I'm going to subtract 91, another 91, whoops, syntax error, didn't like that, 469 minus 91, and then 378 minus 91. Okay, so these values on the left are going to be, we've got 560. 560 for one standard deviation away is going to be 469. That's one standard deviation away. 2 standard deviations away is going to be 378. And then 3 standard deviations away will be 287. Okay, so based on that information, it says, what is the cutoff for the lowest 2.5%? So what I'm doing here is, I know that from here to here is 68% of my data. Then this is another 13.5 here and here, because what that is a total of 95% from here to here. And then from here to here is my 99.7% of my data. So the lowest 2.5% is this information right here. So that would be lowest 2.5% if my minimum score is 200. So it would have to be between 200 and this value here, which is, because you're looking at all this value here, 200 and to 398. Then it says, what percentage of the students have a score of 651 or above? So what they're looking for there is they're saying, well, 651 is around, oh, is this 651? That looks like 651. Oh, so if this is the remaining balance up here, that's what they're looking for here. So I can actually just look at that and say, well, what are my percents? We've got 13.5, we've got 2.5%, and 2.35%, and then this side is going to be a 0.15. So if I were to add those values all up, I would get 13.5 plus 2.35 plus 0.15, and that's a top 16%. So 16% of my students, what percentage of students have a score above 651? So they're looking for this space here, okay? So if I asked you to graph that, you would do this, and you would graph it like this. Now, here's the thing with this. Here's the thing. I would definitely check my answers using my z-score information. So what you know is that using your z-score, okay, remember what your z-score is? To find your z-score, it's going to be the data minus your mean, all divided by the standard deviation. So to find the value for my z-score, we're going to go my data, 651, minus my mean. My mean was 560. And then take that value and divide by 91, which is my standard deviation. So let's figure that out. So we're going to go 651 minus 560 equals, and then I'm going to take that number and divide it by 91, and I'm going to get an approximate answer of 1. Well, what does that mean? That means I'm 1 standard deviation away. So that's 1. However, I need to go look up my chart now. So I'm going to go P of 1 is equal to, now on my z-score chart, which you're going to have on my z-score chart, 1 is 84.13%. Now that means that I'm a score of 651 is. Look at the data. Look where you're at. You're right here. You're 84% better than everybody else, except for they don't want that. They want to know who's above you. So now all you have to do is go 100% minus your 84.13, and I get 15.87%. So if you look at this exactly, see, this is a lot more accurate, 15.87 than 16, but still very close, and you would get full credit for that. What percentage of students score between 378 and 651? Now, we just did the 651. We know 651 gives us an 84.13. Okay, and this is what they're looking for, okay? Here's your 651 right here, right? Here's 651, which is a score. And then 378 is going to be over here. Here's 378. And so what they're asking you here is, I know that this value here is 378. I get that. And I know that I can just count this information between here and here, but that's not what I want to do. What I want to do is I want to show you this by using z-scores so you can be more exact instead of just counting, okay? So in order to do that, well, I guess, and we could do both, I guess, but we know that this is our 84.13%, and we need to find what 378 is, okay? And so we're going to use our z-score table again. So we're going to go z-score equals 378 minus 560 divided by 91. Okay, so we're going to go back over here. We're going to go 378, oops, here we go. 378 minus 560 is equal to, and divided by 91 is -2. Okay, so what that's telling me is this is equal to -2. But we already knew that, P of -2. We knew that because if this is here, right, this is 378, 1, 2. We already know that that's 2 standard deviations away, right? We talked about that earlier. So what you're going to do here now, okay, is you're going to look up P -2. So when I did that, I got a score of, let's see here, 0.0228, 0.0228, which is 2.28%. So basically, they are looking for what's the percentage of students in between here. So you're going to go 84.13. So you have 84.13 subtract 2.28, and that gives you 81% of the, and that gives you 81% of the value of students are scoring in between there. So just another way of doing that. So like again, what we did was we learned how to do this by just counting, and you also can learn how to do this by using the z-score and your calculator. Okay, so a couple of things that I just wanted to stress was that What is influenced or affected by what? So, for example, a mean is influenced by two things. You've got the occurrence in different values. The mode is influenced by only one thing, the occurrence. The median is positional. It's like in the middle. So the only thing that's going to influence the median is another value. Because then it might be slightly off. So the median is not usually affected by an outlier because that's an outlier, and an outlier, it doesn't really matter if it's way out there or in, because when you're finding the mean, you're just counting inwards to the middle. So just a couple of things, just read this through, connections of medians and modes, and how it affects your data. And maybe even experiment. Take a set of data and say, hey, if I have this value, how does this affect my graph? Or how does it affect my data? Does it or not? Now this right here is the statistics review worksheet that you guys all have. And so I'm going to go over the 4 problems on here. The first question says, suppose that taxi cabs in New York City are driven on an average of 75,000 miles per year. You've got a standard deviation of 12,000 miles. Use the empirical rule to find the following. Graph the distribution. So we're going to graph it. So when we graph it, it's going to look like this. You're going to put your average, which is your X bar. That's going to go right here at 75,000 miles per year. You've got your standard deviation right here of 12,000 miles. So keeping in mind when you're going through this, the next value here is going to be 87,000. The next value here will be 99,000. And the third deviation away will be 111,000. Going to the left, you've got 63,000. Keep going, you have 30, or what is that? Subtracting 12, so you have 52,000. And then subtracting, or is that 51? That's 51. Sorry about that. And then subtracting another 12,000 is 39,000. Okay, so what we have here is our 34%. So you're going to put in your values, 34%, 34%. You've got your 13% and your 2.35%. So right here, 2.35. Here is 13.5, and there's your 34%. So they're asking you to fill in the data. So you would say for the 68% of the data, which is from here to here, you would say that that's equal to 63,000 to 87,000. 95% of our data is going to be from 51,000 to 99,000. And then our 99.7% is going to be from 39,000 to 111,000. Okay. Approximate what percentage of the taxi cabs are driven 990,000, which is this value here. So this value is, and so what they're looking for is you're going to draw a graph for that. And what they're looking here is this value inside here, okay? And that's 2.5% of your graph. And that would be, that's it. Okay? That's the value in here. If you check 5,000 taxi cabs, how many of them are driven between 39,000 and 51,000? So they're looking for this distance in here. They're looking for that value right there. So basically, you would just take 5,000 and multiply it by 0.0235 because that's your 2.35%. And that comes out to be 117.5 or a little over 117 cars. Okay. Second question says the number of letters handled daily by a post office is normally distributed with a mean, so this is my X bar, that's important right here, of 20,000 and a standard deviation of 100. find the percent of the days for which it handles. So they're looking for all these values. So I'm going to make my normal distribution chart here. I have my mean of 20,000, my standard deviation of 100. So that's going to be 20,100. Then the next standard deviation, so that's 1. 2 standard deviations is 20,200. And now they already want more than that. So I know what's more than that is all of this space above that. Now, you're going to want to draw this little graph, okay? But let's use z-scores to find the values. I know you can do this by hand, but let's just use our z-scores to be more accurate. So we've got 20,200, subtract my mean, which is 20,000, and divide that by 100. And I get my z-score of 2. I need to look up my z-score of 2. So we're going to go probability for it being 2 is 0.97. So you're going to use your z-score chart, 9772. Okay, and so because that's 97%, so what you need to be aware of the data that you have. What I just found was 97% of my data, which is not this little tiny part here. 97% of my data is from here to here, people. And so what that means is in order to find the remaining part, I need to subtract 100%, or I either subtract 1 minus 0.9772, or I go 100 minus 97.72%. And that's going to equal this value in here, which is going to be 2.28%. So this space in here is 2.28%. Okay. Okay, so the next question says, well, we want fewer than 19,900 letters. So if I want fewer than 19,900 letters, I'm going to go, okay, so I'm going to make my chart again, okay, and then right here is my 20,000 again, and if I subtract 100 from that, I am 1 standard deviation away, which is at 19,900. Okay, so I know that this is -1 standard deviation. And a z-score represents how many standard deviations away I am. So for example, in that first example right here, where we started off at 20,000, I knew that this was 2 standard deviations away. I knew that. I could count 100, 100. And I knew that I was going to get 2 right here, 2 being 2 standard deviations away. The reason why I did it anyways by using the z-score formula was just to show you, because it's not always going to be exactly 1 standard deviation away or exactly 2 standard deviations away. So when it isn't exactly those values, then you need to know how to do that. So that's all. So this is, again, -1, right? -1 standard deviation away. But just to show you, using the z-squared formula, we're going to go 19,900 minus 20,000 divided by my standard deviation here. Because remember, if you forgot the formula, this is it. It's z-score equals xi, that's my data, minus my mean, so x bar, over the standard deviation. So this is over my standard deviation. And by working this out, I get z equals -1. And so now what I need to do is I need to find p of 1, okay? And in doing that, or -1, right? And in doing that, if let's say I only had a positive chart, okay, I'm going to find p of 1 and then subtract. So what I have is 0.8413 for p of 1, because I know it's 1 standard deviation away, it's just over there. So we want fewer than 19,900. So when they say fewer than that, this is what I'm looking for here, this left side data. Okay, so we're going to go, we get 84%. Now, of course, this isn't 84% of the data. 84% of the data would be this way, okay? So this is what's left over from 84% of the data. So we're going to go 1 minus 84% of the data, and so that's going to be about, I guess I should do this, about 0.158, or 158. So that's about 15% of the data. Okay, so about 15. So this value here is about 15%, 15 point something. 15 point, I think it becomes 15.87, something like that. So 15.87% of the data. Okay. All right. For it to be between 20,100 and 20,150, so now, if I look at my graph here, this is what I see, okay? So I know this here is 20,000, right? But if I go over 1 standard deviation, that's 1. Now I'm at 20,100. Oh, and that's what that value is right here, okay? But, oh, and this one for that problem. But the next one is going to be 20,200, and this is in between there. Now, I get this. This is 1. And if you see, 50 is halfway in between here, right? So it's going to be 34% plus half of 13.5%. Okay, so we can add that up, right? We can add, here, let's do that. 34%, 34 plus, parenthesis, 13.5 divided by 2, close the parenthesis, equals 40.75. So I know this space, I know this. Right here, I just added those up, and I just showed you that on the calculator, 40.75. Okay, so I know that that's 40.75. All right, so they want to know what's between that percent. Okay, and so what I'm going to do now is, let's see, what am I going to do? I'm going to do this by hand. And so by doing this by hand between the two of them, I'm just going to do it over here. These are pretty much the same question. So I'm just going to put my work over here. So we're going to use z-scores. So we're going to go, the first one, for this one, z-score is equal to 20100 minus 20,000 all over 100. And then the second one is going to be z equals 20150 minus 20,000 all over 100. Okay, so this right here is 100 divided by 100 is 1. Of course it's 1. We know that's 1 z-score away. This one right here, okay, when we do this, this should be 1 and a half. So I should get 1 and a half. So this should be 150, right? And then divided by 1 and a half. Oh, yeah. And then that's going to be 1,500 divided by half. So 1 and a half. Okay. So what you're going to do now is you have to look this information up. So look this. So we're going to go P of 1.5 is equal to 0.9332. And P of 1, we know this one. We've already done this before. 84.13. And what I have to do with this is I have to say, well, I'm going to go, the percentage is going to equal to P of 1.5 minus P of 1. So what's 1.5? So that's going to be, let's see here, 0.93, 32, 0.8414. Oh, sorry, that was P. 8413. I got this number wrong. Hold on one second. T of 1, that was 1, equals 0.8414. Okay. And when I subtract these two, I get 0.0919, right around there, which comes out to be about 9.19%. So this distance in here is 9.19%. Cool. Okay. So the next problem says, graph the scatter plot using your calculator, find the curve of best fit. So I've done about 4 of these problems here, but just knowing that this equation, when you use this on your scatter plot, and again, I'll show you how to start this, but we did an example like this already. When we plotted the points here, you ended up getting all these points in here like this, and then something like this. So they're asking you, what does this look like? Does this look like a line, or does this look exponentially? What does it look like? And can you back up your data? So basically, you're going to find the regression equation that best models your data. It's possible that there might not be a wrong answer as long as you can support your data. So the 2 equations that it best fits is a linear model, okay, and when you use that, I'll show you, y equals, I think it's like 4.08, something like that, x minus 248. It's on your answer key, etc., but you can look that up. Your R value is equal to 0.91, which is close to 1, which does support a linear model. The other model was an exponential model, and then that equation was y equals 3.83 times 1.036 to the x power. Okay, and this right here, it seems to fit the exponential model better. And so you would write that down, that it fits the exponential model better and why you feel like it does. And then once you have your exponential model, you're going to plug in the information that they give you, and you're going to find the answer to the equation. So for this is asking you for an alligator 100 inches long. So if I use if I feel like this equation is more exponential like this, right, then I'm going to use my exponential model. So I'm going to go y equals 3.83 times 1.036 to the x power, which in this case would be, let's see, I think it's at 100. Yeah. And then, so I get approximately, I think it's, I don't know what it is, 1356 or something like that. 0.19, something similar to that. And then I plug in the next value because it says, well, what about 150? So 3.83 times 1.036 to the 150 power. And so that's like, I think this is 134. Let me rewrite that. And this one, I think that says 794.1 something. Okay, so just to remind you how to do this again is going to your calculator and go to New Document. You go to List and Spreadsheets, and you have to label an A value. So in this case, we're going to call length and weight. The weight is going to depend on my length. My length is going to be my X value here. That's my X value, and then this value here, I'm going to call my Y value. So my length is my X value, so I'm going to call that L, and over here I'm going to call that W. Remember, don't put anything in the middle line right here. Nothing goes there. And so now you're just going to type in all your information. For length, you're going to type in 94, oops, not there, right here. You're going to type in 94, etc. All the values that you have here, 94, then 74, etc. And I'm going to go down, I'm just going to do 3 values. So this is not going to be accurate, but I just want to remind you of how to do this. And the next one is 130 to 51, and then 28, okay? Now remember, once you have this data, you go to Menu, and Statistics, Stat Calculations, and then you go to the linear regression model, okay? And so once you have that, you've got your ym equals mx plus b. What they're going to do is they're going to give you an equation that's a line. And so in this case, they gave us this equation right here, which was this line, okay? And I then can choose to go to make it, I can choose to make it a exponential or a quadratic or any of that. I can just choose to make it different values, okay? So good luck on your statistics exam. I hope this review helped you, and thanks for watching.